Okay, we should be all live and all good. Let me just wait for it to actually load and check. Yeah, cool. Uh, yeah, okay, we're all good. Uh, yeah, nice. Okay, so what did we do uh, yesterday? Yesterday we finished off with our while statements, and we were on this question here. Um, so we were on this question, question 3, because we're now on control loops and we were on lesson 8.8. So let's run the question. Okay. Quiz. Okay, so this is where we were yesterday. So you can see we get all the lines, but we don't get 5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2, 1, 2, 1. Now I wonder if we put this to 5 and then we run it again. No, we get 5, 4, 3, 2, 1. So if we put that back to 1 and we actually add inner, that way outer is 5 and inner is 1. No, that causes an infinite loop. So we'll just try trial and error. Minus, minus. And then what if we did less than? Is that an infinite loop? Yes, that's an infinite loop as well. What if we did 5 whilst inner? No, that would just do another infinite loop, won't it? No, that won't. That would just hang because inner will never be less than or equal to. So what if we go back to that, which I think worked? Yeah. While outer, um, outer. So outer is 5, and while outer is greater than 1, do a new line. Or what if you did that instead? No. If you did that and that, and then if you added outer, would that be an infinite loop? No, that would give you the other thing, the opposite. So if you did that and that and that, no, that won't do anything at all. Uh, hmm. Oh, that's an infinite loop. Where were we originally? That's where we were originally, I think. Yeah. So, So int inner does that need to be 5 because we're doing our inner is no, it can't. It shouldn't be 1. Whilst inner is less than outer, add inner. Is that an infinite loop? No, it's the other way around. Okay, so we're getting there. So we're starting with, so inner is 1. So we basically need to reverse this and this and this and this and technically this. So our outer is 5, but our outer needs to be 1. And whilst, so our outer has to be 1 because we need 1 in the outer. So if we do that, and while outer is less than 5, produce a new line. We don't, so maybe we don't actually want to because we don't want to deduct outer. And then our inner needs to be 5. And whilst inner is greater than 1, greater than outer, then we deduct our inner. And then we don't need to deduct outer because outer remains 1 all the time. Would that be it? Or would that be an infinite? Close. No, so that's just an infinite loop. Maybe if we did that. No, that's another infinite loop. If we did that. Nope. So the closest we've got to is that. Which is just an infinite loop. You can see there. So maybe if we deducted, no, I was thinking deduct inner, but inner finishes. No, inner. I thought inner finished here, but it doesn't. Inner only finishes there. So what if we did inner instead? No. Okay, I think we're going to have to take a look at the solution there, just to see whether I was close or not. So what? Okay. So while outer is 5, and whilst outer is greater than 1. So outer needs to be 5. And then we need to loop between outer and 1. And we don't need this print a new line, and we're deducting outer. Oh, we're using postfix. Okay. Postfix decrement to, so this means we are creating a copy. And then we have it. And then what I also just realized is I didn't have a return 0 either. Okay. Right. Okay, so now we want to do print. We now want to print numbers like this. Quiz, making the output like this. Okay. Now we want to make the output like this. So we want to basically just play around with it. What if we did this? No. So, in the last one, our outer was 5. But in this one, so our outer was 5, i.e. the columns. So could we think about it as rows maybe? So our outer is our rows. Our inner is the columns. Think of it like that maybe. We want to loop between 1 and 5. So the first one must be, so our columns, our rows need to be 5. 1, 2, 3, 4, 5. And whilst the rows are greater than or equal to 5. No, I think inner. We need to do inner here. No, I think we just take a look at this. So our outer. So you can think about it as rows. I didn't look at the answer before you get suspicious. So there are 5 rows. We can loop from 1 to 5. So 1. So whilst outer is less than or equal to 5, inner row elements appear in descending order. So start from 5 and loop through to 1. Okay. And loop through to 1. So our int inner is 5. While inner is greater than or equal to 1, the first number in any row is the same as the row number. The first number in any row is the same as the row number. So number should be printed only if it is less than or equal to space otherwise. So if inner so if the column is less than or equal to the rows, so if the column are less than or equal to the rows, print the column, i.e. inner. So standard character output, inner, else don't print a number. I think that's what that's saying. So you do else standard character output, and then we deduct, use prefix decrement to deduct the column size. No, that doesn't make sense because row elements appear in ascending order. and then we're adding a number, a row. Like that. No. Outer 1. Outer is less than or equal to 5. Inner 5. Whilst inner is greater than 1. If inner is less than or equal to outer. And there we go. No. Deduct inner. No, so we've got a pyramid, but we haven't got what we wanted. So is it my inner while loop? So while int outer, that's fine. While outer is less than or equal to 5, our int inner is 5. So our inner is 5. And then we're deducting the inner each time. If inner to me that looks exactly the same, but obviously it's not. There is something clearly missing. I wonder what it is. There's probably something obvious screaming. It's not inside the else loop, is it? While inner is int outer, correct. While outer less than or equal to 5, correct. Int inner 5, no. While inner is greater than or equal to 1, that's exactly what we have. If inner no, not that. Else print nothing. Then deduct inner. So it was inner that was wrong. So it was this that was wrong. It was the if statement. So if inner is less than or equal to outer, then we will print standard character output inner. And then else we will print standard character output of nothing. Then outside of the else, we will do minus inner. What if we did that just to make it obvious? I'm not seeing where I'm going wrong here. Extra space. Ah, maybe that was it. I needed an extra space. So if we did that. Okay, so it was just an extra space. Okay. Okay. So that was while loops. Now we'll move on to do while statements. No, I don't want to save that. So the outer, we can think, I just want to go back to this one more time. So the outer is the rows. So it seems we can think of outer as being the rows, and then inner is the columns. Although I think maybe the naming should be, I would have thought this would be inner and this would be outer. So let me just rewrite that. So in other words, the outermost while loop is the row and the innermost while loop is the column. That's possibly the way I think of it. And that goes back to this. So the count is 1. And if count is less than 10, then provide 0. Okay, maybe that's the best way to think about it. And then here, whilst it's an if statement, we're still printing a new line. And therefore that creates a new column. Because if count is count divisible by 10 remainder is remainder 0, then produce a new line. Okay, maybe that's something to consider going forward. Okay, do while statements. So consider the case where we want to show the user menu and show the user a menu and ask them to make a selection. If the user chooses an invalid selection, to ask them again. Clearly the menu should go inside a loop of some kind. So we keep asking the user a valid, but what kind of loop should we choose? Since a loop evaluates a condition up front, it's an awkward choice. We should solve the issue like this. So include, as always, our input-output stream. Then we have a return type of integer for our main function. So selection must be declared outside the while loop, just like we did here with our number of rows. So int, just like we would do with a nested while loop and rows and columns. So selection, and then we're going to make this unassigned. And we're going to make this unassigned. Okay. Value is uninitialized. Uninitialized, aka has a value of 0. That makes sense. So our while loop. So while the selection is less than 1, or selection is greater than 4, we will continue to loop through this. So standard character output, please make a selection with a line break. That makes sense. Standard character output 1 addition line break. Standard character output 2 subtraction. Standard character output exertion operator 3 multiplication. Standard character output exertion operator 4 division. Then we will allow the user to enter their choice with the insertion operator, of selection. Do something with, yeah, and then outside of the while loop, we will do something with the selection. So let's just, yeah, such as a switch statement. So you would do case one, you would do switch selection, case one return. Let's actually try that. Switch, and then selection, and then we will do case one, return, you have chosen to, you have added. No, it would be like this. And then case two, you have subtracted. Case three, you have multiplied. Case four, you have divided. And then you would do standard character output selection like that. So instead of doing that, semicolon, let me just clear the terminal and run it. Maybe it's because we need to do that. Yeah, it is. So we actually need to do that. Standard. So in that case, I assume we wouldn't actually need. See, this is a good way to learn, I think. Well, obviously I do because I'm doing it. But we did that. Everything's all good. Because even though they said do a switch statement and they haven't shown us, if you actually do it yourself, you now know or remember or remind yourself that when you have a string inside a switch case, you don't need a return. You can't leave it empty, so you need a standard character output. So I am going to choose 4. So I should get you have divided. You have divided. You have divided, and then so what we'll do is we'll do space. And then here we'll do that. So I'm going to do 1 now. You have added. Why is that? That's why, because so no. So why did maybe it's because you have multiplied these on because we would need a break, surely. Because the reason why that's happening. Yeah, okay. So, remembering things. Is it break or return? We'll find out. How about that? Would that work then? So if we did division, you have divided. Okay, now let's add that back. Let's do addition now. You have added. Cool. So we needed a break. What happens, just out of curiosity, what happens if we did return? We did return, and we did return. Would that stop it? It possibly might, because if you did divided, that would be false, and it wouldn't reach divide. Let's have a look. Yeah, well, we get errors, so we don't need return. It is break. Okay, so let's do multiplication. You have multiplied, and let's just by, you have multiplied. You have multiplied, and chosen option 3. Option you have divided as you selected. I want selected. Okay. So let's do 2. You have subtracted as you selected option 2. Cool. But this only works because our initial value for we have to pick a different initializer to represent invalid. And now we're introducing magic numbers into our code. So do while statements. So to avoid using magic numbers, as these should generally be avoided, we can use do while statements. Okay, so ignore that, that's fine. Actually, I'll just, if you wanted to, you could just do that. Anyway, that's pedantic. And then, so we could fix it like that, but do while statements would be better. Okay. We still good? Yeah, we still good. Right. To help solve the problem above, so to help solve the problem above, yeah, we can use do while statements. The syntax for this for do while statements is do, then some statement, and then while, and then condition. So a do while statement is a looping construct that works just like a while loop, except the statement always executes at least once. After the statement has been executed, the do while loop, so the do statement executes and then it checks the while condition, right? The while loop then checks the condition. If the condition in the while loop is true, the path of execution jumps back to the top of the do while loop and it executes again. So for example, our modified example would turn into this. So we'll get rid of that. We'll do it all over again. So include, again, input output stream. Input output, include input output stream with a return type of integer for our main function. And then our selection, so int selection uninitialized So we want to execute this at least once. So we want to execute the do statement at least once. So do, and then I'll just copy and paste. Then, once the do statement has been executed, the program will then check if the while condition is true. So then we do while selection is less than 1 or selection is greater than 4. And then we do standard character output. You have selected option, and then whatever the option they selected. And then we return 0. Let's add that or run that. And then we do 3. You have selected option 3. So in this way, so by using a do while statement, we have avoided magic numbers and additional variables. One thing worth discussing is in the above example is that selection variable must be declared outside the, okay. Also the selection variable must be declared outside of the do block. If said variable were to be declared in the inside the do block, aka here, then it would be destroyed when the do block terminates, aka this closing bracket here. So hopefully that makes sense. Again, these things make sense, but then I need to actually figure a way to use my mind and brain to actually use them correctly. Which happens before the condition is evaluated, i.e. this. But we need the variable in the while condition, consequently the selection must be declared yes. Terminates. Okay, so in practice, do while loops aren't commonly used. However, the condition at the bottom of the loop obscures a loop condition, um, which can lead to errors. Many developers avoid using do while loops, will take a softer stance, and advocate for preferring while loops over do loops. Okay, interesting to know. Uh, okay, four statements. Okay, I think I'm going to take a quick break here, and I'll be back, and then we can get on to four statements. And these you come across four statements. I personally find a lot more than while statements. Anyway, I'll be back in a minute. Okay. How are we looking on the audio? Still good? Let me just check. Yeah. Okay, so right, for loops. So for loops. So in C++, for loops are the preferred looping statement to use. So the syntax for loops is for, then the initializer, statement, then the condition we're looking out for, and then the expression, aka usually increment or decrement. Then we do the statement. Cool. The easiest way to initially understand as to how a for statement works is to convert it into an equivalent while. So you got the initial statement. That's interesting. I never actually compared for one while. A for loop in written as a while loop would be something like this. So you got so you got the block here, we got a block here, you got an initial statement, you got a while, then you got a statement, and then you got an end expression. Okay. No. So evaluation of for statements. A for statement is evaluated into three parts. So the first is the init, aka the initializer statement. We still good on the stream? I noticed maybe the frame rate has dropped. Oh no, we're back. Okay, good. This only happens once the init statement is executed. This only happens when the loop is initiated. The init statement is typically used for variable definition and initialization. Remember, we can use also the comma operator, and the only thing that will be used in the for loop, I believe, is the one to the right. These variables have local scope, which is really just a form of block scope. These variables have local scope, aka just a form of block scope. So the second is the condition. This is the thing that is evaluated after every iteration. If it evaluates to true, the statement is executed. If false, then the loop terminates. Then 3, the end expression. Typically used to increase or decrease the loop variables defined in the init statement. Okay. The order of execution is so let's try it then. So we got include, as always, our input output stream. We have a return type of integer for our main function, and then we have a for. So we got our initializer, which will be an integer of I, and we'll assign that to 1. I want to make a space there. Then a semicolon, and then whilst the condition, so whilst I is less than or equal to 10, we will increase I. Then, with a semicolon, then we will produce a standard character output of I, aka this, and then we'll do a space. And then outside the for loop, we will do standard character output, and we'll do a new line, and then we'll return 0. That's why, because it was I, not 1. Okay, so let's clear my terminal. Just going to get rid of both of them. So we'll run that, and now we will run that, and we'll get 1, 2, 3, 4, 5. But we don't get a new line. So we declare the loop variable name I here. Then we're looking out for the, and that's initialized as 1. Then we have to set the condition to loop through, i.e. when I initialized as 1 is less than, whilst I is less than 10, then we will increase I. And this is what it would look like. This is what it would look like if we had used a while loop. So you got the, and remember we would need to use a nested block to put our while loop in. So let's do even more examples. Another for loop example is, because practice is always the best way to learn something. So we'll do again, include our input output stream library in our header, and then we will do a, okay, what we'll also do is we will include our C standard int to give us access to this no, I don't want to save that. I wanted to save this. So standard int 64t, then pow int base int exponent, and then we're doing a standard int 64 total, and then we're setting, we're initializing total as 1. Then we're doing a for loop. So we'll do int I. We could use equals, but we're going to use 0. And then we're going to do if I is less than exponent, then we will prefix I. And then we will do total times, we're going to be timesing the base. And then outside the for loop, we're going to return total. Semicolon. Yeah, so the reason why that's not running is we don't have a main, but that's okay, that's fine. So returns the value base exponent and watches for overflow. The function returns the base to the power exponent. This is straightforward increment. So we have our initializer. If I is less than exponent, so if our initializer of 0 is less than exponent, then we will increase, we will go through the loop, and we will have total timesing by base. That is a bit more of a complicated one, but we practice it, so. And I want to make a note of that because I know when I come back to this, I will not have an idea what it is all about. So for loops can also be used to with decrements as well. So for example, again, include input output stream, and then we'll do int main and then we're going to be counting down from 9 to 0. And so our for loop will be int I of 9, and then we're going to be the condition we're looking out for would be I, if I is greater than or equal to 0, yeah, greater than or equal to 0, then we will do we will decrease I, and then we'll do standard character output I, and then a space, and then we will do a standard character output, a new line, and then we'll do, as always, return 0. Run it, and we get 987654321 Cool. Such as then we can also use for loops to change the value of more than just 1, such as and then we'll do, again, we'll practice, include input output stream, return type of integer for our main function. We'll do for int I, we'll set it to 1, and then whilst I is less than or equal to 10, we will do I plus equals 2. Then we will print this. We will print I with a space, and then we will do a standard character output of a new line. And then, as always, return 0. Run it, and we get 1, 3, 5, 7, 9. We could also get odd numbers. So if we change that to 2, I assume we would get 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Cool. Or in the example here, he did 0. But I'm going to do it like that. Feel free to play around with it as you want. So, for example, if you did 5, you would get 5, 7, 9, I assume. Yeah, 5, 7, 9. And if you did just 7, you get 7 and 9. And so on and so on. Just play around with it if you really want to. Okay. The perils of the not operator. Avoid the not operator when doing, the best practice is to avoid using the operator does not equals when doing numeric comparisons in the for loop condition. Prefer operator less than or operator less than or equal to, or even operator where possible. And I assume that also applies to greater than or greater than equal to. Off by 1 errors. Okay, one of the biggest problems that new programmers have with for loops are off by 1 errors. Off by 1 errors occur when the loop iterates one too many times or one too few times from the desired result. So, for example, we use the less than rather than less than equal to. So again, practice, include input output stream, return type of integer for our main function. Then we're having a for loop where our initializer is 1. And then we are, if I is less than 5, we will add to I, not to 1. Then we'll do a standard character output of I, and then a space. And then we'll do a standard character output of a new line, and then return 0. So without trying to look at that, we're initializing as 1. We are then checking the condition to see if I is less than 5, then we add 1, and then we're printing. So we would possibly expect to get 1, 2, 3, 4, 5, but the loop will stop here when it's less than 5, i.e. when it's 4. So when it's 5, it won't run. So we should get 1, 2, 3, 4. And we get 1, 2, 3, 4. Whereas if we had used the less than or equals to, we would get it. If we had used the less than or equals to for, we would get 5 included in the output. And let me just show you that, for example. No, not equals, not minus, equals. So we'll run that, and we get 1, 2, 3, 4, 5. Okay, omitted expressions. It is possible to write for loops that omit any or all of the statements of expressions. For example, we'll omit the init statement and then expression, leaving only the condition. That's what he means. Okay, interesting. So let's do that as well. So we'll stream return type of integer for our main function. Then we'll do initialize I as 0. Then we'll have a for loop with no initializer, but a condition of I when I is greater than 10, and then no increment or decrement, or no end expression. Then we'll do a standard character output of I, and then we'll do that, and then in here we'll increment I, and then we'll do a standard character output of a new line, and then return 0. Let's see what happens there. We still get the full 1 through 9. And if you wanted 10, as always, you could just do this. Cool. But that works because we have initialized I here. So the for loop knows what we're talking about. Yeah. Although you don't see the following would produce an infinite loop. So for our initializer, our condition, and then our expression, and then statement. Yeah. Okay. Although for loops typically iterate only over one variable, sometimes for loops work with multiple variables. No, need to work with multiple variables. To assist with this, the programmer can define multiple variables using the comma operator, like I mentioned earlier, and can make use to change the value of multiple values at the end of the expression. So, okay. Let's practice that then. So we got our for loop, we got our initializer of int x, and we're initializing x as 0. Then we have y of 9. Then our loop will be whilst x is less than 10, we will add to x but subtract from y. And then we will do a standard character output of x and then a space, and then we'll do y and then a new line each loop, and then outside of the for loop we will return 0. So that should produce 0, 9, 1, 8, all the way to when this gets to 9 and this gets to 0. X won't reach 10 because we've set it to be less than 10. So that's what I would expect. Let's have a look. Yeah, cool. 0, 9, 1, 8, 5, 4, 9, 0. The above for loop will produce the following. Nice. Nested for loops. Okay, so we can have a for loop within a for loop, just like we can have a while loop within a while statement within a while statement. So again, let's practice. Include input output stream, return type of integer for our main function, setting up the for loop, and we're initializing char c as a. Then while c is less than or equal to e, we will add to c. Remember, we can use this or we can add characters because characters are integral types. You can see there we have char, but we have 97. Yeah, because of the A American something something something, but the acronym is ASCII. So we will do a standard character output of C, which prints the letter, then a nested for loop, and then we'll have a for integer I, and we'll initialize I as 0. I don't like the spacing. And then whilst the integer is less than 3, we will add the integer. And then we will produce a output of I. And then still within, I just realized I need a body for this. Still within our outer for loop, we will print a new line for every loop of the outer loop. And then we will return 0. So let's have a look at what that does. So we got A 012, B 012, C 012, D 012, E 012, because we're looping through E, and our nested loop will only go from 0 to 2, aka this. Cool. So basically, the outer loop takes control. The outer loop, that's annoying. The outer loop takes control first, and then that's the one we're looking out for. So it prints a letter. Then the next statement or expression is this, and then we loop through this, i.e. we go from 1 to 3. Then once this is done, we print a new line. Once that's done, we print a new line, and at this point we've reached the end of the outer loop, and we begin again at B. Cool, that all makes sense. Variables used inside a loop should only be defined inside a loop. This will reduce the output of, where am I? There. variables used only inside a loop should be defined inside the loop. I.e., such as this. I. Okay. So, conclusion. So, for statements are the most common used, and a loop variable modifies at the top, which help reduce error. Even though the syntax can be a bit confusing, you'll get to know them in no time. For statements, excel when you have a counter variable. If you do not have a counter variable, a while is probably the best choice. Okay. And then he obviously used a for statement. That's what he's trying to get at. Haha, very funny. Anyway, right, let's do a quiz. Question time. The good old classic fizz buzz. Okay, so I'm going to take a break here and then we'll be back and we'll do the quiz questions. All right. See you in a minute. All right. So let's continue with for loops and the questions. Okay. So write a loop that prints every even number from 0 to 20. Okay. Now we'll do quiz, write a for loop that prints every even number from 0 to 20. Okay, so we'll get rid of this. We'll include input output stream. We'll do a integer, we'll do a return type of integer for our main. And in the body, we will do a for loop that prints every even number from 0 to 20. So for, and then we have our initializer of, we'll do initializer I of 0 because we want to include 0. Then if I is less than or equal to 20, that's the condition we're going to be looking at for, we will increase I. Then does he want, no, we'll do it on a single line. So we'll do a standard character output, and then each loop will be I. And then we'll do a, once the loop is finished, we'll do a new line. And then, as always, we will return 0. So if we clear our terminal, so we're initializing as 0. Oh, every even number, my bad. So it should be I plus equals 2. Because we want an even number. Because this would just do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 all the way through. But we actually need to do this I plus equals 2. So we then get 0, 2, 4, and so on. That's annoying. Sorry about that. I'll just move that up. So what we'll do is we will run that and see if it works. So can I get rid of that? That's probably easier. Okay, so I run that, and there we go. But we need a space. So what I'll do is we'll do that, and hopefully that looks a bit better. Cool. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Nice. So we know that works. And then our output. Okay. Let's see if there's anything different to that solution. Ah, yeah, the same. Write a function named sum2 that takes an integer parameter named value and returns the sum of the values, returns the sum of values from one to value, i.e. sum5 should be 15 because you're doing 1 plus 2 plus 3 plus 4 plus 5. Hint, use a non-loop variable to accumulate the sum as you iterate from 0 to 1, much like POW. Okay, write a function name. I'm going to, what am I going to do? I'm going to make sure it runs. Actually, no. Forget what I was going to say. So include input output stream. We'll do a function name. We'll do a int sum2, which takes an integer parameter and returns the sum. So return takes an integer called value and then returns sum, int sum, and then we do that. So then in our main function, we will be doing in our main function we will be doing a for loop. We will be doing int x, and then so int I that, and then whilst I is less than or equal to x, we will increase I. Then we will call sum2 and then x. But we also want to ask the user standard character output, enter a value to return the cumulative sum of all the numbers from 1 to the value. Let me just do that. So actually what we want to do is we want to set I to 1 then. And then we'll do sum, and then we'll allow the user to standard character input I think we actually need to get rid of this, to be honest. But so standard character input value. I think what we should do rather is we should if we get rid of that, no. Like that, but that doesn't feel right. But what we'll do is we will do return 0. Let's just see. So we're asking the user to enter a value. We're setting the sum to add the value. We're allowing the user to enter the value, and we're returning the sum. And then we're in our main, we are creating an X function, uninitialized, and then we're creating a initializer of 1. And whilst I is less than or equal to X, for example, 5, we are adding 1. Let's just have a look. So we don't get any result. Okay, which means something is wrong. What if we got rid of that and we returned value instead? No. I seem to always get confused with functions, so I'm going to do it over again. So I'm going to do int. I'm going to do a sum function, and I'm going to do I'm going to need a sum. I'm going to need int x as well, and then we're going to have a for loop, and we're going to initialize integer of I to be 1, and then whilst I is less than or equal to x, I will, maybe you need a postfix, and then we will do sum plus sum equals sum plus x, perhaps. That's right. And then we want to return standard character output sum. Actually, for now, what I'm going to do is I'm just going to make sure that it works. I'm going to do 10 sum plus equals sum. 0. So no. So something is going wrong. Is it that? No. One, 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 one. So standard character output, enter a value for the cumulative sum from 1 to the value. Then we will create an integer for that value. And then we will also create a int of sum. So and then we will do a standard character input of value. So then the sum is that. So whilst I is less than or equal to value, you increase that, and then you sum sum equals sum plus value. Enter a value from 1 to 10. If we did 3, we would get 1 plus 2 is 3, so we should get 6. We get 9. Okay, so somewhere's going wrong. So if we did, what if we did a value? 3, we get 3. What if we did 1, sum, then sum plus equals value, and then we did 3, we still get 9. So something is definitely going wrong here. So we're initializing it as 1. And we're going through the value. What if we did that and we wanted to make a copy each time? 9 is less than value. Six. Cool. So that was how we did it, or was supposed to do it. So we did that. It's fairly straightforward. We created a value, which would be our parameter in here. Then we allowed the user to enter the value. Then we did a sum. So this, I assume, can all go in here. But then where would your value go? So that means if we did this in here, would that still work? Where the value is, we want to call so sum2, and it would be sum, correct? That. So let's clear that. Let's run it again. And do we still get 6? We get 3. So something is going wrong. Six. Yeah. Oh no, sorry, wrong one. Whoops. Int total. So he's put it in there. So we got int total, i.e. the sum. The sum needs to be 0. Okay. Int sum2, int value. And then our total is set to 0. And then we return total. Okay. So int sum2 with the integer value of that. So then we're doing an int total, which is this, the sum. So we'll do sum, but we need to make the sum, we need to initialize the sum. So that's what we were missing. Then we do the for loop. So we'll do that. Then we do the for loop. So we get rid of that. We can get rid of sum. We then do the for loop of integer I is initialized as 1. Then, so without looking, when I is less than or equal to value, we will increase I, and then we will print I. Then we will print we will do sum plus equals value, and then we will print standard character output sum. So that means we can get rid of all this, and in our main function we can just call sum2, and then actually what we should do is int x, sum2x. Yeah? because that is going through the sum, and we want to return the sum, and then we can do sum, and that won't cause any naming conflicts. Correct. Let's have a think first. So sound character output, that's fine. That's fine. No, because we're not actually providing the user, we're not allowing the user to enter a value. We get 9. Because we need to do, it's plus I, not value. Because we're looping through I until we reach a value. Okay, that does make sense. And we get 6. Okay. So we'll just do that. And that's how we did it. Okay, how are we on the time? What is wrong with the... Okay, so I don't think we'll move on from for loops today. What is wrong with the following loop? Print numbers from 9 to 0. So the first thing I would say is potentially that this is wrong because it should be unassigned and we'll get overflow. If we got rid of unsigned, we would have an int of I9, and whilst I is greater than or equal to 0, deduct 9. So I think it's unassigned. Okay. All right, FizzBuzz. A FizzBuzz question. Okay. Okay, FizzBuzz. FizzBuzz is a simple math game. Also, the rules are the following. So, starting at 1 and counting upward, replace the number divisible only by 3 with the word fizz. So, starting from 1 onward, replace the numbers divisible by 3, aka using the modulus, with fizz. Those divisible by 5 with buzz, and 3 and 5 with fizz buzz. Implement the game inside of a function that takes a parameter determining what to count up to. Use a for loop and a if-else chain, meaning you can use as many if-else as you like. So we'll go from 15. So first of all, we create our main function. We'll simply return 0. And then here, for now, we'll do if 0, and then end if, and then we'll do fizz buzz, and then we'll do 15 here. Cool, so now we'll create the fizz buzz. So, no. We'll do int x. That way we can ask the user to enter. So int fizz buzz, and then we'll do an integer of value, and then we'll do a standard character output of enter a value for the, and we need an include input output stream, input output stream for the fizz buzz game. Then what we'll do is we'll create we've already created the integer value, so we'll allow the user to enter the value. Then we'll do a for loop starting from 1, int I 1, and then int I 1. Don't worry, I'm not looking at the answer, I was just checking the time. Whilst I is less than or equal to our value, we will iterate over the loop. Then inside here, we will need to use if statements and else statements. So we will do if value modulus 3 is equal to 0, then we will do a standard character output of fizz. Else if value divisible by 5 is equal to 0, then we will return standard character output of buzz. Now we have two options here. We could do potentially if the value of 3 and 5, or we could do 15. But that might cause an issue because we'll do if else if value divisible is divisible by 3 is equal to 0, and value remainder 5 is equal to 0, we will print standard character output fizz buzz. Else we will just print the value. So that's our for loop, and then we need to return value like that. Then if we, why am I, no. Then if we get rid of that, and we get rid of that, does that compute? Is that all good? All okay? So let me clear that. Let me run that. Enter a number for the FizzBuzz game. Let's do 15. Fizz, 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 fizz. That'll just produce an error, won't it? What about if we did, we returned value back. And we actually did, the first if statement is if value remainder 3 is equal to 0 and value 5 remainder 0, then we return FizzBuzz. Then we get rid of this. Would that work better? FizzBuzz, fizz. No, so we need to maybe take out, take this out maybe, and then standard character output value, perhaps. No. Like that. No. Oh, that's why, because else if. Maybe that's the reason why. No. For integer I, whilst I is less than value, um, fizz. So anything over 15. Feels like we're close. Into a number 6. Buzz. No. Um, ah, because it shouldn't be value we're checking. We want to do I. That makes sense now. It says, and then it will still be wrong. I return a value. 15? No. So you got fizz. 1, 2. No. So 15 is producing 15. Is that because we need to make a standard character output? No, static cast and change the type. That is one possibility. Use a for loop and a single if-else chain, meaning you can use as many else if as you like. What about if do you have to remove this out of the for loop? So if 0 and what I'm just going to do is I'm just going to do a standard character output, and then I'm going to do value and then a space. I'm just going to see if that works. Enter a number, 15. Enter a number, 15. So that works. Standard character output. Okay. But then why then? Standard character. What if we then got rid of that, brought it back in? So if I divisible by 3 and 5, then we get the output of that. Maybe it's because, no, that's the switch statement. I'll do 15 again. Okay, we're getting closer. So we got that. But then we're just going back to exactly what we did again. Do we need to declare them outside this time? So we do, if we do all of this, maybe that's the right way to do it. But then we won't be looping through. Let's have a look at the solution. We're doing a void because we're printing, aren't we? Should have found that out. That way we don't need to return that. So then that should all be good then, because we don't need that. So I don't want to look at that now. So it's just a void function. Should have realized that. Hopefully you realized that way before me. So now if we were to run it, clear, and we're going to do 15, we still get that. Maybe we needed to reintroduce the 0. Is that way? Yes, it was. So we needed to add back the modulus equals 0. So, and for every loop, I want to do a standard character output, and then I want to do a space, just to make it more spacey. Kevin. Cool. So we finally got there. So the only thing I was missing was that it should have been a void. And we use void when we're printing stuff. Okay. So this is solely printing something, therefore we don't need to have a return type. Okay. What about if you made it simpler and you did if I divisible by 15 is equal to 0? Would that make it better? Or would that be the exact same? So let's do 30. And what I actually want to do is I want to change. Yes, it does. So we got 30 there and we got 15 there. Cool. So that's one way to do it. I feel that potentially we could use a switch statement to make it even easier. Okay. And I'm just going to add a line break actually. Okay. And then we get fizz, buzz, fizz. Stop. No, because then we're getting 2 now, aren't we? If it's divisible by 3, if it's divisible by 5, but then 15 is divisible by, so does that mean we'd need to move this further down for it to work? Else, so I'm just playing around here. Else if I is less than or equal to 15, or no, so if I remainder 15, divisible by 15 remainder, divided by 15 has a remainder of 0, we have a standard character output of like that. Enter a number, 15. No. Okay, so we'll just return it back to its original. Of that. I'll do 20. Yeah. And we're still getting fizz buzz. Now we're getting fizz. Ah, that's why. Because we needed the else if. And we get fizz buzz. Cool. So I was like 90% there, but wasn't 100% there. Close, but no cigar. On that classic fizz buzz question. Okay, how many questions we got left? Fizz pop. How long we get? So we'll probably go for another 15 minutes. Hopefully, I get this. Modify your fizz bump program for 7 to pop. Run the program over 150 iterations. If you're using so what we could do is else if I divisible by 7 is equal to 0, we print pop. We did 9 and we get pop. But, so we know that that works. Why is that not creating a new line? Now it is. Okay. So, perhaps this is where we need a switch statement. So, inside our if statement, if we do a switch value and then we do a case case of or can we introduce Boolean here? We could do a bool div like that. We'll set it to false. No, we cannot. We want to use a switch statement, I assume. But you want to switch the statement of the value. So if we did bool div no, because then we'd have to call it in here. So optimize your function so only 4 if statements are used. 1, 2, 3, 4, 5. So that works, but it's not it's very, very basic. So if value I feel like there's so many different directions that I don't actually know which direction to go in. We could create a Boolean function, but that would just complicate things. We could switch the value. We could switch the value of I to case I divisible by 3. I don't think this is right syntax. And I remainder 5 equals 0, and I remainder 7 equals 0. And you see there, it's wrong. No, I think I'm going to have to look at the answer, to be honest. Bool printed false. So we're not using an if switch statement at all, but we are using a bool. So a Boolean printed, and then we don't actually need false because false is by default. So we can get rid of this. And then we do this. If 0 divided by 3 is that, then printed equals true. Else, if printed equals true. But why are we getting errors? Expected a statement. Oh, because we're expecting a statement? Because we're going through each loop. And then printed equals true. And then get rid of this one. If is not printed, then we do a standard character output of I. Then outside of that, we do a standard character output of a new line. Expected a statement. Ah, no. Ah, what am I doing, man? It's because I didn't include the brackets. Yeah, exactly. What is wrong with me, man? Because we've included 2 lines in the if statement. That means oh, that's because this needs to become if, and so does this, right? Let me run that. 150. So it is 105. Is that right? Pop fizz. Okay, so we get rid of the line breaks. Did we make a note down? I just want to make sure. Yeah. So what we had to do was introduce Boolean and then make the else if statements into just if statements. And then I want to clear my terminal and I want to run it one more time. 150. Fizz buzz pop. Okay. So, sort of got that, sort of understood it. The first part. The only thing I was missing was the void. The void function. Okay. Well, hopefully you did it a lot quicker than I did, or well, at least hopefully you did, and didn't have to look at the answer. I mean, I was close, but it was just the void, and it was the void, and what was the other thing I missed? I think was it just a void, or am I just gaslighting myself? Yeah, it was the void. It was void, and because we made it void, we didn't need a return here. Yes, that was the reason. Okay, and because we're only printing it because we're asking the user to enter it. Okay. Now this one is okay, and I think this is probably a good place to stop. So we'll do this. We'll do the solution here. So you can include. So you can include a Boolean inside of a for loop. Okay. Hopefully, I think what I'll do is just off stream, I'll repeat and repeat and repeat. Because I was so close, but no cigar. But you know, what are you going to do? There's always next time, which is true. Okay, so we've done this for a while now, so I think what we'll do is we will go to the next section. So break and continue. I assume that's with switch statements. Yes, it is. So we will. No, I don't want to save that. So we left off at lesson 8. Well, and also just going back to trying to learn. These streams are a good way for me to go back and see what I was doing wrong as well, rather than having to read through. I can just watch the video and so can you, if you're struggling as much as me. But hopefully you didn't. But if you did, you did. And at least you learned from it. Or hopefully you did. So lesson 8.8, 8.11, break and continue. Yeah. So how long have we got on chapter 8? Okay, so break, continues, halts, random number generation. Okay, and then error handling. Nice. So we'll probably, I would say, finish chapter 8 next stream. But for now, I keep saving that. So day 16. Just want to check, is the stream named day 16? It is, good. So day 16, and what did we do today? We did we finished off nested loops. Nested while loops. We did do while statements and when not to use them. And then we did for loops for basically most of the stream. For basically most of the stream. Then we did for loops and the various operators. For loops, so we have our initializer, then we have our condition, then we have our expression. Then we did for loops and one-off errors. Then we did omitted expressions, multiple counters. Then we did nested for loops, variables inside, variables only used inside the for loop, should be defined inside the loop. And then we did quiz, for example, fizz, buzz. I'm including the quiz this time, which I haven't done previously, because I want to know where we did fizz buzz and what day I did fizz buzz on. Okay, tutto bene. And today's date is the 14th of August. Cool. If you've been following along, hopefully you've been enjoying it as much as I have. Hopefully you did fizz buzz and those questions a bit better than I did. But if you didn't, hopefully you learned is the main thing. And tomorrow we will do break and continue. Yeah, so as always, comment what you think I did well or what you enjoyed. Comment what was so obvious that I did wrong that I can improve on. And as always, just comment in general whether you're liking it or not. So yeah, please like, subscribe, comment, all that good stuff. And enjoy C++ is the main thing. And I'll see you in the next one. Bye.